Hello everyone, my name is Sid. I would like to present my Geography 778 final project, Future of Wind Turbines and Viewsheds, a quantitative approach. Today I would be talking about the introduction, problem statement, solution, workflow, and I will a kind of brief demo and for future work. For introduction, wind power continues to be one of the fastest growing and lowest cost sources of electricity in US. And it means that large scale wind projects gonna come in the future, and these projects definitely come with a cost of affecting our visual scenic quality and also the visual aesthetics of our surroundings. Today, I would like to introduce you to few key terms that I would be using for, and also what would like to you to understand, which is one is distance zone, which is nothing but effect of distance over a turbine. If you see the static image here, turbine 1, 2, 3, these are all three same turbines, but turbine 1 seems to look larger rather than turbine 3. And the same thing here with the turbines, the moving turbines on your right. So increasing distance from an observer, turbines tends to be smaller, and therefore it can be perceived as not larger, even though they are given that on the same scale. The second key term is visual exposure. Is the amount of turbine that's visible. Here, the blade end is visible. The dark gray part is not visible. The light gray part might be visible. So here, the stem part is called the hub. And if the total turbine is visible, it's called the rotor sweep visibility. It means that the complete turbine is visible. And next, we would be talking about visual prominence. Visual prominence is how prominent is a is a turbine in a wind farm. If you see scenario 1, scenario 2, you will clearly understand the same location with and without a wind farm. With a wind farm, it's definitely more kind of conflicting with the scenic quality. And turbine 1, as you can see, it can be little more prominent than turbine 2 because the first is the distance effect, and second one is the amount that is actually exposed to the observer. If you see as an observer, definitely turbine 1 has more kind of effects. So the main problem I tried to identify as part of this project is there is no open source Python tool that's there except GIS, which is written back in 2014. And according to a paper by Professor Palmer, most of the wind energy VIS used standard commercial software like ArcGIS Pro. This made me wonder, like, why not come up with a solution of open sourcing the visual impact assessment using open source geospatial tools and I did end up developing a viawind library, which abstracts the geospatial workflow to perform visual impact assessment of onshore wind turbines. And we would be starting with the data sets, wind turbine location and digital elevation model. These are for the Blackjack Creek project in B County, Texas. And we would be all using the open source libraries you can see in italics. And I would be scrolling through the whole GIS workflow that's being automated or packaged as part of the Python library. So you start with with the data sets, you compute relative viewsheds for the blade end height, hub height, and rotor sweep. Then you reclassify these relative viewsheds. After that, you merge these relative viewsheds for each wind turbine location. That's how you end up with the visual exposure raster. You start on your left. You first compute a multi-ring buffer, which is a non-intersecting concentric buffer. You rasterize the multi-ring buffer. You burn different values beneath it. That's how you created a distance zone rasters. Now you merge these two rasters. You basically perform a raster sum. Then you reclassify these values to get visual prominence raster for each wind turbine location, meaningful visibility raster for each wind turbine location, and you sum all of them. That's how you end up with cumulative visual prominence, which is a visual prominence raster showcasing the amount of visual prominence at every single location within the project. And a cumulative meaningful visibility raster would have the meaningful visibility, which is reclassed as per table 4 of Professor Palmer's research paper. And then you perform the raster division. You divide the visual prominence by meaningful visibility. That would give you the mean prominence raster. Then you bind these minimum raster values. You basically extract for each point location of the wind turbine. You bind back into the data frame. And I would show a brief demo like how it would look, how the package will look. So it's pretty easy. All the installation steps are laid out. From the viawind package, you download the calc visual impact. Then you input the dataset paths for the wind turbine, shapefile or CSV, and also a digital elevation model. Then you set up a directory where it has to store. And that's how you have initially created an instance. Now you just write a single line, which is run via a pipeline. This would perform all of this GIS analysis just with a single line. You can see it started the pipeline, the blade and view sheds. It created all the relative view sheds. It reclassified the view sheds as per the workflow, and then performed a raster merge for each single location, then did the multi-ring buffers, and then reclassed all of this for the visual prominence and meaningful visibility, and then summed for each single turbine location to aggregated it for the whole project level. That's how you end up with the mean visual prominence. And furthermore, we have to calculate the visual impact for the project. Then you can see that the VIA perform visual impact would be creating a kind of the visual impact map that you would be looking for. And here you go. This is the turbine visual prominence map. And this is the mean turbine prominence that we got out of the project. And as you can see, this is the mean prominence of the wind turbines. These are like pretty much same. And that's how we got our analysis. And next, furthermore, we also calculated the visual impact map. As you can see, this is the visual impact map that Professor Palmer did using ArcGIS Pro. And we also created the visual impact map. As you can see, this is showing the visual impact of the project scope. And here you can see it's the same kind of map. Currently, we are here in the deployment stage where I did deploy an alpha version for the demonstration. The users are feel free to go and take there. And I would like to provide some credits to Professor Palmer, who did give a very valuable feedback. I would like to thank Travis Williams, Professor Gartner, Randy Sinclair, and my friend Mahita for helping me out regarding the try and exception cases and also kind of perform testing. And this is the viawind package, and it also allows like kind of interactive visualization. As you can see, you can just run a few of these visualization. For instance, I would like to see a merged view shed then for turbine 1. So it's as simple as you just enter these options. The package would interactively go into the directory. It would find these files. And for this wind turbine location, this is the cumulative viewshed, the cumulative reclassed viewshed, or the visual exposure viewshed, as you can see. So this is how the project would be rolled out. And you can also find a lot of other functions that are part of the package, the calc visual impact module. Once you click the help, you can see that it has quite a number of functions to create relative view sheds, turbine buffers. It can reclass. You can see all the visualization functions here. And that's how. Thank you so much.